2018 short questions for higher level. This is question A3, so it's dealing with a bridge. It says that the curved support pillar of the bridge is based on a parabola which is inscribed in a rectangle. V is the vertex of the parabola and P is a point on the curve. So we've got a parabola, or half of a parabola. It's basically the top half of a parabola like you see here in the bridge. Vertex is down here, so the parabola is turned sideways, and we've got some of the construction already done. So it actually leaves it straightforward. This first part is very, very straightforward. They've given us the first half of the construction. In other words, we are going to divide up this side into equal spaces. They've given us the division. And I'm just going to copy that division up along. And so it means that they've divided up into 1, 2, 3, 4, 5 sections. So I just copied it out. Likewise, they've given us the distance for this section, the vertical section of it. And I'm going to divide that up. We'd normally divide it from the vertex. So when I come along, I'll just divide down the way because that's where they put the measurement to start with. It should be 5 as well. And it is. So in other words, they've given us the divisions. And that's done. Meaning, I can just very, very quickly draw out my... Sorry, I made a mistake there. So as we did with the first line, or they did with the first line, we're joining to the vertex. Each one comes back to the vertex. And always, from the vertex we have a broken line. One set has to go parallel to that broken line. So it's the kind of way you figure out which is which. So I've got my construction lines all in. We normally label number 1 to start at V. 1, 2, 3, 4. Come around to the corner. 1, 2, 3, 4. Line 1 will cut line 1. Line 2 will cut line 2. Line 3 will cut line 3. I've got my points. Now I can sketch in the parabola. Now, second part of the question. Some of these questions are worded that they sound more complicated than they are. So F is the focal point of the parabola. That's fine, we have the focus. The point P is anchored to the bridge surface axis by 2 cable stays. The line PF is 1 cable. So in other words, all you have to do there is draw line PF. That's one of the cables. The second cable is inclined at a tangent at 25 degrees to a tangent at P. So this is what sounds complicated. You have to draw a cable inclined at 25 degrees to a tangent. All you take from that is they said tangent at P. Even if you were confused by how this question is done, I'd be looking there, tangent at P, I'm going to draw a tangent at point P. It can be handy to come back with a sketch. This is the eccentricity method. So they're mix and matching two of the methods here. The box method for drawing the parabola, and you've got the eccentricity method. We've got our construction for the eccentricity method. The directrix, the axis, the focus and the vertex are equal distance apart, so that distance is going to be the same. We've always got our 45 degree line vertical and 45. This line is going to be at 45 degrees, and we've got the construction. But if I want to draw a tangent to that parabola, so I'll just take up here, we'll call it point P. Tangent to the parabola is always F to P, and we join horizontally to the directrix. So we take our angle, we create that angle. This is again is horizontal or parallel to the axis line, and we just bisect that angle. So for me to draw that tangent, I come along and bisect that. And my tangent would be here. So that's a tangent to the parabola. I come along to this question and I can do the same thing. I don't have the directrix, but I don't need it. I could go and find the directrix if I wanted to. So if I wanted to find the directrix, for example, I can say F to P, which is a point here, that's the vertex. P to D is the same. So we said that distance from the sketch was the same. So I could draw the directrix up here, but I don't actually need it. Just draw it because that's how you would find it in the question. So there's the directrix. I want to draw a tangent. I joined F to P back to the sketch, and we joined our line horizontally across. So we just came straight across to find our line. Now I've created an angle, and it's just the same thing. I bisect that angle. So just as we did in the sketch, I'll bisect that angle that I've created. that gives me a tangent at point P. So there, I've drawn a tangent at point P. The only difference is they said the cable is inclined at 25 degrees to that point P. So it just means I come along with my protractor and set up an angle at 25 degrees. So 10, 25. And the line they're actually looking for is this one. Even if you didn't understand that and you didn't get it, it wouldn't really matter once you drew the tangent. So again, as I said, as soon as I heard tangent to point P, that's the main thing I was concerned about, because that's where the construction comes from. That's that question done. Question A4 is a planes question. So it could be the oblique plane or the same as intersecting planes. It's all the same topic. So we have a spider cam. So they're talking about the 4 wires joining to a camera like you would have on a football pitch. Find the dihedral angle between planes OAB and OAD. So we've got 2 planes, OAB and OAD. I'm going to highlight them just slightly. Don't you do it. I'm just doing it so you can see them. So I've highlighted the 2 planes just so you can see them. Like I said, don't do that in the leaving cert yourself, because you'll be covering up your construction lines. Now, we have to find the dihedral angle between the 2 planes. Dihedral angle always deals with the line of intersection. Here it's OA. As always, for dihedral angle, we find the true length of line OA and we find a point of view of line OA. So it's going to be auxiliary elevation, auxiliary plane. To find the true length of line OA, we project out at 90 degrees to it. So I'm going to project off my auxiliary elevation at 90 degrees to line OA, which is our line of intersection. So I project out at 90 degrees and I'll bring the 4 points out. XY line, and 90 degrees to those lines, and we'll call it again straight away, it's X1, Y1. I'm drawing an auxiliary elevation, so my heights need to be taken from elevation. So for the height of A, I take off the height of A. Follow it out, gives me the height of A. I'm taking out the same, so just to show again, that's my height for D, and I projected out D, so I found my height. My line of intersection is AO, so here's my line of intersection, and that's a true length. And my 2 planes are AOB and AOD. Here we have AOB and AOD in behind. Doesn't matter whether you show construction lines or not, or broken lines. Those are my 2 planes. That is my auxiliary elevation showing the true length of OA. Now I want to find a point view of OA. To do that, I need to draw an auxiliary plane looking along the line. So I'm going to look along the line OA, and I'm going to project out all my points parallel to that line. So I'm looking along line OA. XY line comes in. It's a new XY line, so it's X2, Y2. I drew an auxiliary elevation. This is our auxiliary plane. And again, if I'm drawing a plane, I need to measure from plane. And I measure from the previous XY line. Distance for A. Previous XY line into plane, here we have it. That would give me A. Previous XY line to B. And here I have it. Previous XY line to D. And previous XY line to O. And that should sit in the same position as A. So AO, we get a point view. So I end up with AO here, point view of the line. Here is our point D, and we have our point B. And we draw the plane. AOD is an edge view, AOB is an edge view, and that gives me my dihedral angle. If you don't want to write dihedral angle, you can just measure the angle. You can get your protractor and just measure the angle. That is our dihedral angle done. And as we showed, just our distance from XY line to A was taken from the previous XY line into plane. That was our distance. We took that and struck it off. Now, part B of this question, determine the true angle between cables AO and AB. There's 2 separate ways to do this, but they involve the same thing. We can use the same rules as we have before. So it's the first time we'll have done this. So they're saying we want to determine the angle between cables OA and OB. we take that to mean a plane. If we want to find the true angle between something, or the true length of two lines on a plane, we basically treat it all as one plane. So I'm going to take this as one plane. Our standard way of finding the true angle between two lines is we'll find the true shape of the plane. If I want to find the true shape of this plane, it's auxiliary elevation, auxiliary plan. Looking first for an auxiliary elevation along a horizontal line. So AOB, here I have AOB in elevation. I can draw horizontal line from A across in elevation, and I get point P. I come down and I find that in plan. So point P was on the line BO. Point P is here. Sorry, point P is on BO. Point P is there. That gives me the horizontal line AP. The reason I've done that is when I want to project an auxiliary elevation, I need to look along a horizontal line. That's going to give me the edge view of the plane. So I'm going to project my auxiliary elevation out here. And exactly as we did before, XY line. So it's just a new auxiliary. And again, I can call this X1, Y1. It's the first one of those. Taking my points, height of B, exactly as we did before. So take your 3 points. Here's my height of B. I'll take out B. Height of O. Take it out. And height of A. And I'm expecting this to look like an edge. So when I come out, A. So when I go to draw this, I've got O, A, and B. When I draw this in, they should line up to form a straight line. There is my edge view of the plane. Now I need to find the true shape by looking in at 90 degrees. So for me to see the true shape of that, I have to look in here at 90 degrees. Meaning I'm going to project now my auxiliary plan off at 90 degrees. And it's going to come back in on top of the other question, but that doesn't really matter. So I'm going to project out here at 90 degrees. I'm going to tape on a piece of paper so you can see it. You could also project it out this side to leave some more room. And we might even do that. It might make things easier. So the direction doesn't matter once it's at 90 degrees. So I project out A, B, and O out this side. And again, the same rules apply. I'll set up my XY line. I'll set it up out here. X2, Y2. So I'm drawing an auxiliary plan, the same rules apply. I'm going measuring from the previous XY line. So I'm going to be measuring back in here. And you can see I'm going to need a piece of paper down the side. Okay, I've stuck on my piece of paper. As I said, I was projecting out my auxiliary plan looking at 90 degrees to my edge view of the plane. Set up my X2, Y2 line. And I'm measuring again. I'm drawing auxiliary plan. I'm measuring from plan. And I measure from the previous XY line. So I'm on X1, X2, Y2, I'm going from the previous one. So my distance for O, from X1, Y1 to plan, and I set out my distance for O. Previous XY line then back for B into plan. Take my distance for B. So again from my XY line, out. And last one then A, so from X1, Y1 back into plan. Follow it out, and I measure from my XY line. That gives me my plane, the true shape of the plane ABO. There's my true shape of the plane. The question asked for determine the angle between OA and OB. OA and OB, here is the angle. When I see the true shape of a plane, I see the true angle of all three angles, and I see the true length of all three lines. So if they said find the true lengths of each of those lines, you could do the same thing. If they, for example, asked you to draw a line at 90 degrees to OA from B, it's the same process. It's here I could do that. So if I want to set up now a line from OA at 90 degrees and draw it from B, I could do that here. So that would be an example of what this would be used for. So the true shape means you can basically do anything with the plane. But when I see the true shape, I can draw any angle I want. And as I said, I see the three real angles and the three true length. That's the question done.